Hi guys, this is O-Level Chemistry, paper 11, June 2022, question 11. Two statements about the structure and properties of metals are given. Statement 1, metals are malleable and have high melting points. And statement 2, metals have mobile electrons in their structure. Okay, so what is correct? Now they're asking us whether the two statements are correct or not, and there is other text as well. Let's look at the options. A, both statements are correct, and statement 2 explains statement 1. Both statements are individually correct. Yes. Statement 2 does not explain statement 1. Statement 2 is talking about mobile electrons, whereas statement 1 is talking about malleability and high melting points. So they are not related. They are all different properties of metals. B, both statements are correct, but statement 2 does not explain statement 1. Yes, statement 2 is an individual statement. C, statement 1 is correct, but statement 2 is incorrect. Wrong. Statement 2 is also correct. Statement 2 is correct, yes, but statement 1 is incorrect. Wrong. Statement 1 is also correct. So, the correct option for this question is option B. Question 12. How many different elements are present in ammonium nitrate? Ammonium, NH4, nitrate, NO3. Ammonium nitrate. So we have got nitrogen present, we have got hydrogen present, and we've got oxygen present. One, two, three. We have three different elements present. So this makes option B the correct option for this question. Question 13. Aqueous calcium hydroxide is an alkali. It is neutralized by dilute nitric acid to produce calcium nitrate and water. What is the ionic equation for this reaction? Okay, so we have an alkali reacting with an acid, and we are talking about the ionic equation. So we need to remember that H positive ions from the acid react with OH negative ions from the base, resulting in the formation of H2O liquid, water molecules. Rest of the ions are spectator ions. So if you're talking about the ionic equation, we need to look at the equation for the formation of water only. So this makes option D the correct option for this question. Question 14. The relative molecular mass of a liquid Z is 60. Okay. Z contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. Which row shows the correct empirical and molecular formula of Z? So let's calculate them. Carbon, hydrogen, and oxygen. So first off, their percentages. Carbon is 40%, hydrogen is 6.7%, and oxygen is 53.3%. So in the first step, we divide these by their ARs. Carbon has 12, hydrogen has 1, oxygen has 16. So we end up with values of 3.33 for carbon, 6.7 for hydrogen, and 3.33 for oxygen. In the next step, we divide all of these values by the smallest value. The smallest value here being 3.33. So we divide each of these with 3.33, and this gives us a ratio of 1 is to 2 is to 1, based on which we end up with the empirical formula of CH2O. So options A and B have CH2O. Options C and D do not have CH2O, so C and D have been eliminated. Next, now we have CH2O. The MR of CH2O is 12 plus 2, 14 plus 16, which gives us 30. The MR of Z is 60. So 60 divided by 30 gives us a value of 2. How do we use this 2? We multiply CH2O by 2, giving us C2H4O2 as the molecular formula. So now A has CH2O as the molecular formula, which is wrong, but B has C2H4O2 as the molecular formula, which is correct, making option B the correct option for this question. Question 15. How many tons of aluminum oxide are required to produce 27 tons of aluminum? So we have this equation Al2O3 giving us 2 moles of Al. Now in this we have Al2O3 which has an MR of 102 and this produces 2 moles of aluminum. So AR of aluminum is 27, 27 into 2 is 54. So 102 tons of Al2O3 produces 54 tons of aluminum. And they're asking us how much Al2O3 would be required to produce 27 tons of aluminum. So we can calculate this 27 upon 54 into 102. This gives us a value of 51. So this makes option B the correct option for this question. Question 16. Lead to bromide is electrolyzed using inert electrodes. Which statement is correct? A brown gas is seen at the positive electrode. Positive electrode is where reduction takes place. So, oh, sorry, positive electrode is the anode. It is where oxidation takes place. So, oxidation taking place, the species would be Br negative ions. So, 2 moles of Br negative producing Br2 vapors and giving off 2 moles of electrons. So, a brown gas is seen. So, the color of bromine vapors is brown. So, this option is correct. B. Electrons pass through the solution from one electrode to the other. Electrons pass through the wires. This is wrong. Ions pass through the circuit from one electrode to the other. No, the ions pass through the solution. This is also wrong. Lead ions are oxidized. We just saw that bromide ions are oxidized, which means lead ions, Pb2 positive ions, will accept those two electrons and will be converted into lead metal. And this is the process of reduction. So lead ions are not oxidized, lead ions are reduced. This makes option A the correct option for this question. Question 17. Compound X is sodium iodide. Compound Y is methyl methanoate. Okay. At room temperature and pressure, dash solid in aqueous solution dash electricity. Okay. Which solid conducts or does not conduct electricity? And okay. Which word correctly complete gaps 1 and 2? Now, compound X is sodium iodide and Y is methyl methanoate. Y is an ester and X is an ionic solid. So, both X and Y are solids? No. Esters are liquids. This is wrong. B. Both X and Y are again wrong. Only X is a solid? Yes, sodium iodide is a solid. So, options A and B have been eliminated. Now, in aqueous solution, dash electricity. So we have both X and Y conduct electricity. Esters are not known to conduct electricity. So this option is incorrect. Only X conducts electricity. Sodium iodide is an ionic salt and in solution ionic salts do conduct electricity. So this makes option D the correct option for this question. Question 18. For the forward reaction of a reversible reaction, the enthalpy change of reaction is -50 and the activation energy is +60. What is the activation energy for the reverse reaction? So let's make the diagram, the energy profile diagram for the forward reaction. This is the diagram for the forward reaction. We have now these are the different labels we need to put. So this is -50 and this is +60. This is the forward reaction. So when we convert this into the backward reaction, so the products become the reactants and the reactants become the products. So now we will consider this as the enthalpy change. In the forward reaction, this was minus 50. In the backward reaction, this would become plus 50. And this energy gap would remain as plus 60. So these being the reactants, the energy gap from here till the maximum value becomes plus 50 and plus 60 plus 110. So this should be the activation energy for the reverse reaction. So this results in option D being the correct option for this question. Question 19. The diagram shows a titration experiment. Which row about the reaction in the conical flask is correct? The reaction is, now this is a reaction between an acid and an alkali. It is a neutralization reaction, and neutralization reactions are always exothermic because energy is given off. So it is exothermic, making options A and B incorrect. Now we will select between options C and D. The value of delta H. So if it is an exothermic reaction, the value of delta H has to be negative. A positive value means the reaction would be endothermic. So this makes option C the correct option for this question. Question 20. Sulfur dioxide reacts with oxygen in the air, and the equation and the enthalpy changes are given. The reaction is very slow if no catalyst is present. Okay, we need to recall the catalyst present is V2O5. Which statements explains this? Air contains only 21% oxygen, so there is not enough oxygen for all the sulfur dioxide to react. No, we do not use air directly from oxygen because it contains 21%. We have our supply of oxygen. Obviously, it is taken from air, but we have our own supply of oxygen. B. Only a small proportion of the sulfur dioxide and oxygen molecules have enough energy to react even at high temperatures. Yes, this shows that the activation energy requirement is high. And activation energy requirement being high, the catalyst is required to lower it. So this is the correct option. C. The reaction is exothermic, and so at high temperature, the equilibrium shifts to the left. Okay, this does not make the reaction slow. It does shift to the left, but reaction being slow, the term is used for the forward reaction. So this does not apply to the forward reaction. D. The reaction is reversible and so products turn back to reactants. This happens more quickly at high temperatures. If equilibrium is reached, then the rate of forward reaction is equal to the rate of backward reaction. Whether the temperature is low or high, it will have no effect on the position of equilibrium after the equilibrium has been reached. So, wrong. So, this makes option B the correct option for this question.